Now that we've learned how to make measures of variability in R, let's take a look at how to make bivariate tables in R. So recall that in an earlier video, we made a data frame called dataset, which includes the values of some variables from the 2012 General Social Survey. Let's take a look at a namespace for that data frame. And so if we go to our output window, we can see that we have variables like year and ID, children, age, education, father's education, sex, race, and so on. A number of different variables that we can work with. Okay, so going back to my script, let's say that we wanted to create some measures, some bivariate tables. The first thing that we're going to do is to do some recoding. I've noticed that in my version of the data set, there are some values that are listed that I actually don't want to be shown in the table because they indicate some kind of a missing value, and I just want to recode them. And so I think the easiest way to recode in R is to use something called the recode command, which is part of the cars package. So what you should do here is basically just install this package named car. I've already installed it, but you should just run this. And that way you'll have the car package as part of your library. And then once you've installed it, just bring in the car package. And now you can use any commands that are part of the car package. And so I'm going to be using the recode command. Before I do that, I'm going to basically show you a little bit of a convenient shortcut that you can use, whereby you don't have to directly reference the data frame that your variables are included in. And so you can do that by using the attach command. And so attach is just going to basically give you kind of a programming convenience that automatically references the data frame. And so we're going to attach it here, and then later when we're finished, we're going to detach it. That's going to be kind of at the end of the session, so I'll get back to that when I'm finished. So now that I've attached it, I no longer have to use dataset to reference the variables in the dataset because they're already going to be automatically referenced. And so when I use a variable like health or happiness that was in the original namespace, I no longer have to put dataset $health or happiness. R automatically knows how to do that because I've used the attach command previously. Okay, so now I'm going to use the recode command to recode the values of health. And I'm actually going to create a new value of health. Notice that I've made this one lowercase, which is going to be equal to the values of the old values of health recoded. And here's what the recode is going to look like. In a vector, I'm going to include the values 0, 8, and 9. I'm going to code all of those equal to NA, which R recognizes as missing. And notice that this is in parentheses. So if I run this, it'll basically take the values of 0, 8, and 9 of the old value, capital health, and recode it into the values of the new variable, lowercase health. And they're going to be automatically put into the data frame dataset. I'm going to do the same thing with the variable happiness. The old variable is going to be recoded to the new variable, which is lowercase. I'm going to take the values 8 and 9 of the original and code them into missing of the new variable. So if I run those two together, the recode should have been done properly. And just to check it, I'm going to run a table on both my new variables, health and happiness. The lowercase values incidentally, are the ones that are new. And if I look at it, I see that for health, I have done it correctly. I only have 4 values. And for happiness, I've done it correctly. I only have 3 values. Now, notice that I don't have any value labels attached to this. My dataset didn't come with those. So I actually have to designate these variables in such a way that I can attach value labels to them. I'm going to show you how to do that in just a second. So going back to my script, I'm going to use the ordered function. Now, both of these are ordinal variables, right? So basically, what I'm going to do is I'm going to designate them as ordinal variables with this ordered function. So I'm going to take health, designate it as an ordered variable, indicate its levels, that is, its raw codes, and it takes on values from 1, 2, 3 to 4. I'm going to specify those as a vector, and these are basically the levels of the variable, that is, the raw values. And I'm going to label each one of them. And I'm going to label them, again, using a vector. And so the labels associated with each of these different levels, 1 is going to be excellent, 2 is good, 3 is fair, and 4 is poor. So if I run that, and I make it a new value, health, because I've attached it, it's going to put it in the data frame dataset. I'm going to do the same thing with happiness. I'm going to designate it as an ordinal variable. I'm going to take the original values of happiness, indicate the different levels, 1, 2, and 3, and label them as very happy, pretty happy, and not too happy as part of a vector. So if I just run these two things, again, because I've attached it, it will make them part of the data frame data set. And it'll overwrite the existing values of health and happiness that I recoded here, attaching value labels to those values. And so now what I can do is I can actually create crosstab or contingency tables with my new variables. And so I can use the table command, and if I put two variables in it, it'll make a two-way table. And so if I go to my output window, so you can see I've got a nice table in which I have the values of happiness arrayed along the rows, and then the values of health arrayed along the columns, and then I have cell frequencies for each one of these things. So if we just wanted to read one of them or two of them, we have 164 people who say that they're in excellent health who are very happy. We have 31 people who say that they're in poor health and are not too happy. Okay, so now that we've done that, let's actually look at some ways in which we can improve this, make a better looking table. So for one thing, what I could do is I could store these values, and I can store them in an object called myTable. And then I can use that to create some other values. So let's say that I wanted cell frequency, cell percentages. I can use the prop table function along with my object to show the cell percentages. And so if I run this and I print it showing only one digit, and I go back to my output window, now I've got the cell percentages, actually the proportions. Right, so about 13% of people who are in this data set indicate that they're in excellent health and they're very happy. 2% say that they're in poor health and not too happy. Okay, well, what if I wanted different percentages, or in this case, proportions? What would I do? Well, I would just include a number as an option following the data object on which this command is run. So if I run the prop table command on my object, my table, and I use a 1 option after that, that'll give me row percentages. And if I use a 2 option, that'll give me column percentages. Right? And so I'll just run both of these together to show you the difference between the row percentages and the column percentages. And we can see how they compare to the cell percentages. Okay, so the first group here is basically going to be my row percentages. So they're going to sum to 100 across the row. And that means that of the people who are very happy, 40% are in excellent health, 44 are in good health, 11 are in fair health, and 4 are in poor health. And we can interpret any one of these rows in the same way. Now, if we were looking at the column percentages, then we would just read them up and down, right? And so basically, we can see that this is showing us basically contingent on being in some level of health, what proportion of people are in the various levels of happiness. And so if given that somebody has excellent health, 47% of them are very happy, 46% are pretty happy, and only 7% are not too happy. Okay, so that's all fine and good, but that doesn't really give us anything approaching a publication quality table. So what I would recommend is to use an alternative approach, and that involves installing a package called gmodel. So I would just say use the install packages command to install this gmodels package. Just run that. I've already got it installed, so I'm not going to do it myself. And then bring that package in using the library command function. So now you can use any commands that are part of that gmodels library. Okay, and the command that we're actually going to use is something called crosstab. And with crosstab, you're going to get something that looks very much like what you'd get from output from a standard statistical package like SPSS or SAS. And so we have to just feed a couple of arguments into our crosstab command. So the first thing I'm going to do is I'm going to basically give it the values of my independent and my dependent variables, in this case, happiness and health. And so I also need to tell it whether I want things like column proportions, row proportions, chi-square values, totals, and then what format do I want it in. So I'm going to say that I do want column proportions. I'll set that to true, although I don't want row proportions. I'll set that to false. I also don't want the chi-square calculated, although in a later video I will actually show you how to calculate this. I also don't want the total, so I'm going to leave that as false. and then I'm going to want it to look like an SPSS output. So I'm just going to make the format equal to SPSS, and that's fed in through a vector. So if I just highlight that and I run it, and I zoom in on my resulting table, notice that I've got a table with both cell frequencies and column percentages, and these are to three decimal places. So I'm going to get some results that look very much like what I've already gotten in the past, but this is just a nicer format. This is something like you might get from a package like SPSS or SAS. In this case, this is made to look like an SPSS version. And so here we have kind of a key showing us that this is the count or frequency, the cell frequency, and then the column percentages. And this tells us how many cases were used in the analysis, 1,299. So that's a really nice way of showing bivariate analysis in R. And just as housekeeping, the last thing we should do is we should detach our data set. Doing that basically just means that the data frame isn't referenced directly. So now every time that we want to reference a variable within the data frame, we have to go back to referencing both the data frame and the variable separated by a $sign. But since we've attached it earlier, we should detach it just so that we're being consistent. We don't screw up any later code. So it's just good housekeeping to pair, attach, and detach when you're finished. And that basically is how we create bivariate tables in R.